From the lavish resorts of Las Vegas to the legendary skyscrapers of New York and the record-breaking towers in Malaysia and Taiwan, mankind is testing the limits of construction. How high can high-rises climb? Who built these towers and why? Today, we're going to find out the secrets of the most spectacular skyscrapers on Earth. Skyscrapers were created for the simple purpose of giving people a place to work. They're built where land is scarce, where property values are high, and there's nowhere to go but up. In addition, over the last 100 years, skyscrapers have become symbols of technological progress and corporate power. The tallest are the result of the battle to rule the skies, an ongoing war to build the highest office building in the world. Nowadays, their names are well known by everybody. The Sears Tower, the now disappeared World Trade Center, the Empire State Building.
What skyscrapers have is a power to engage people's imagination, emotion, memory. Skyscrapers are buildings that people can be proud of collectively.
The thing that drives the real tall buildings is really ego, and it's really the need for a society to sort of position themselves in the world as having a technological image. We did it, New York did it at the turn of the century to show Europe that we had arrived. And in a sense, Southeast Asia is doing it now to show that they've kind of re-arrived, because it all kind of started there in the first place.
This is Kuala Lumpur, the capital city of Malaysia. Once this was a poor nation that made its living exporting rubber, timber, and palm oil. Then Malaysia became the world's chief exporter of semiconductors, and a tide of new money has helped it rise out of the developing world. Kuala Lumpur is filled with new skyscrapers, none grander than the world's tallest buildings, the Petronas Towers.
We never planned it to be the tallest building in the world. First major challenge to the architect is that we would like to have a building which is distinctive, which is impressive, and which will incorporate several elements of our own traditions. Because while we look toward the new millennium to be an international country, we also would like to be rooted in our tradition.
Rising 1,483 feet into the air, the Petronas Towers are the last great engineering achievements of the 20th century. They are also bold symbolic statements of economic power and national pride. Architecturally, they are a steel and glass fireworks display. This project began with a competition. World-class architects were asked to design 2 office towers that would stand at the center of Kuala Lumpur, and therefore at the heart of Malaysia. Architect Cesar Pelli's winning design consisted of two symmetrical towers, joined at midpoint. Pelli based the tower's shape on an Islamic arabesque pattern. Two squares form a star that symbolizes the relationship between heaven and earth. The 8-pointed star creates a 16-branched form. The main circular columns of the towers were nestled into these branches. Two smaller towers were then joined onto the main towers, providing even more office space and structural support.
I felt that for the towers to be identified with Kuala Lumpur and Malaysia, the most important thing was to design towers that would not look like towers that one has seen in New York or Chicago or Frankfurt, but towers that would have an image that one could forever on associate with Kuala Lumpur. I like to give the example of the Eiffel Tower. We associate it with Paris and France, but it has nothing to do with the tradition of architecture or the character of Paris before it was built. And if it would have been built in London, we would think it was a very British tower, and if it would have been built in Berlin, we would think it is a very German tower. The same with the Kuala Lumpur towers. They have been built in Malaysia, and they will be forever associated with Malaysia.
The task of turning Pelli's grand vision into steel and concrete reality fell to structural engineer Charles Thornton.
One of the plights of the structural engineer is that very few people know what we do. The mass press tends to always give credit to the architect for the whole project, and the public therefore tends to think that the architect does all those things, whereas, you know, there are mechanical engineers, electrical engineers, plumbing engineers, and structural engineers, elevator engineers, exterior wall engineers. But the structural engineer is probably the person with the most responsibility, because if we make a mistake, the potential loss of life is unbelievably large.
Thornton and an international team of engineers built the state-of-the-art skyscrapers using indigenous materials and native workers. More than 7,000 men and women had a hand in constructing the towers. Their first task was laying the building's foundation. An enormous pit was excavated, then filled with 17,000 cubic yards of concrete. Trucks pulled up non-stop for 2.5 days to pour their loads. When the foundation mats had hardened, laborers began piecing together the skyscrapers. The Petronas towers are wrapped in stainless steel, but underneath they're made out of high-performance concrete. Until recently, concrete wasn't strong enough to bear the enormous weight of a skyscraper on slender, economical columns and walls. But the concrete used in Petronas is 3 times stronger than the conventional kind. This super concrete helped engineers find a way around the problem of acceleration. Every skyscraper moves in the wind. People only notice when the movements are large or jerky. The taller and thinner the skyscraper, the worse the acceleration.
There are buildings in the United States where chandeliers will swing, water in the toilet bowl will slosh around, and we've done plenty of studies, and we find out that at certain accelerations, people start to feel nauseous. And the biggest problem we had on Petronas is that on that kind of a height-to-width ratio building, to keep the accelerations within the limits that people will not get seasick, literally, is really the major challenge.
The concrete frames of the towers dampen their movements through friction. When the wind blows, walls rub against ceilings, and ceilings rub against floors. This causes microscopic cracking in the concrete, which is normal and harmless. The microcracking soaks up energy, reducing building sway. The other great challenge builders faced was lifting a 192-foot-long sky bridge to the 42nd floor. Unlike the towers, the sky bridge is made almost entirely of steel. This makes it strong and flexible, but at 750 tons, it's also very heavy. It took 3 days and nights to jack the bridge into place. Lightning strikes twice blew out the lifting machinery's controls. But eventually, the bridge was successfully joined to its colossal parents. The sky bridge sits in a precarious position because each tower moves separately in the wind. To keep the sky bridge from being damaged as the main towers move, each end of the bridge is allowed to move in and out and rotate left and right on sliding bearings, pins, and expansion joints. The arch that supports the middle of the bridge keeps the bridge centered between the towers, no matter how they move. Three years after construction began, the towers were topped off with twin pinnacles. Each pinnacle stands 20 stories high. Inside, the buildings are corporate, with an Eastern flavor. The towers include a Muslim prayer room called a sarau. There are two entrances, one for women and another for men. Eventually, the towers will harbor 10,000 workers. Each building has over 2 million square feet of floor space, 48 football fields, so there's room to grow. Getting all of those people to their offices takes a big elevator system. Buildings this size require a lot of cars, but elevator shafts take up valuable floor space, which loses money. The solution used here and in other super tall buildings is to have several double-decker elevators share a shaft. Visitors to the upper half of the towers transfer at the 41st and 42nd floors to two local shafts. Then they grab elevators that stop at either even or odd floors depending on what floor you start from. Sound confusing? It is. Like employees everywhere, the people who toil inside these $2 billion office buildings are probably unaware of how much effort went into creating their workspace. But for the builders, that's not the point.
I'm delighted with the buildings. I'm really very, very happy, particularly because now you see it all over Kuala Lumpur and the whole valley. From places that I had never imagined you would see. It has given Kuala Lumpur a great new silhouette, a magnificent silhouette.
Some people have said that it is a monument. Well, we would like to say it is a statement celebrating the success of Malaysia and also to provide the people with a sense of confidence so that they will be able to develop the art, culture, science for the betterment of the human race.
For nearly a century, Bethlehem Steel has manufactured the bones that lie beneath the skin of the modern world. Over the years, their plants have churned out more than 850 million tons of steel. Steel frames support the most famous buildings and bridges on Earth. The Golden Gate, the Chrysler Building, and Rockefeller Center were all born in this inferno. Steel manufacturing hasn't changed much in the last century. First, cold scrap is dumped into huge furnace vessels. Then molten iron is poured on top. The mixture is cooked inside a machine called a blast oxygen furnace. The furnace pumps superheated air into the vessel, raising it to 3,000 degrees. Rapid oxidation turns the scrap and iron into steel. The red-hot steel then passes through a series of machines that cut it, cool it, and pound it into shape. Today's steel is lighter and stronger than it was in the first half of the 20th century. Scientists have found ways to alter its properties by adding elements such as aluminum, vanadium, and boron into the mix. But even in its relatively raw form, steel transformed the world. Its incredible strength under tension and compression made it possible for mankind to build higher and faster than ever before. Before steel, most office buildings were made out of brick or masonry. Their walls carried their weight. Brick buildings could only climb a few floors before they collapsed under their own bulk. And then in the late 1800s, engineers began building around frames of steel. By spreading the weight across a skeleton of high-strength steel beams, buildings were able to reach unprecedented heights. But it took the invention of the elevator to make skyscrapers a reality. They're found inside the central core of every tall building. Virtually everyone has had the experience of riding in an elevator. Many of us are destined to walk into these metal boxes thousands upon thousands of times, where we will be hoisted into the air by a metal cable channeled through an elaborate system of pulleys and winches.
28 floors.
We take them for granted, but without elevators, there would be no skyscrapers.
Going down.
When the Otis Elevator Company invented machine-powered lifts in the late 1800s, it set off an explosion in building. New York and Chicago were ground zero. New York's Fuller Building, better known as the Flatiron, was one of the first to earn the name skyscraper. Standing 22 stories tall, it towered above the city. But within 30 years, the Flatiron had been dwarfed by an army of steel and concrete Goliaths. America had emerged as a world power. Money was pouring in, and business was showing off. That money allowed architects and engineers to push the steel frame to its limits. They produced dozens of buildings that remain among the tallest and best-looking skyscrapers ever to pierce the clouds. For many, the image of the Empire State Building is what springs to mind when they hear the word skyscraper. Though it has become an icon, the Empire State is still a busy office building housing everything from lingerie designers to software engineers. Architect Ronette Riley is one of its 25,000 tenants.
I've been in the Empire State Building 11 years, and it's a fabulous place to have your office.
We can buy a ticket for the observatory.
Around the corner. And
You walk in every day, and the lobby is so beautiful. I really feel like I've arrived someplace. I used to work for a very famous architect, and I wanted to be in the most famous building if I couldn't have his position. So I looked around the city, and this was my first choice. People, before they even know who I am, they know where I'm at. So that has helped attract potential employees and clients who know there's an architect at the top of the Empire State Building.
We need to see samples of these against the yellows before we approve it.
2 yellows, and what are the numbers?
The building moves. It's quite amazing. I think it has a 2-foot displacement, and every once in a while, especially when I'm wearing very tall high heels and I'm walking by a window that's open, I can feel the building move back and forth, and it's given me vertigo a couple of times.
Okay, smile.
Each year, the 25,000 people who work inside the Empire State are joined by 3.5 million visitors. Most of them have come to see New York from the building's 86th floor observatory.
One adult.
Unlike most office buildings, which do their best to keep the public out, the Empire State has always embraced the curious crowds from around the world who come to see what it's like at the top of New York City. Since it opened in 1931, more than 120 million people have gazed down from the 86th floor. Higher up, electricians install the gels that light up the building's tower at night. The gels change color for holidays. For instance, red, white, and blue for the 4th of July. Like a movie star who's aging gracefully, the Empire State keeps its looks by undergoing a strict regimen of grooming and health care supervised by an adoring staff.
The Empire State Building is a very unique building. I mean, this building is known all over the world, wherever you go. It's certainly a classic. You couldn't build another one like this if you wanted to. This building was so overbuilt, electrically and physically, that they could have probably gone up another 100 floors and still maintained the structure. We have a lot of machinery in this building that you couldn't duplicate again. We have motors that are running since the 20s, and they're still going. We refuse to buy new replacements for them because they wouldn't have the same lifespan.
The Empire State consumes 40 million kilowatt hours of electricity every year. Small towns use less power. The building is strung with 473 miles of electrical wire, enough to stretch from New York to Detroit. It takes 7 electricians to keep all the circuits functioning. They are just a few of the Empire State Building's 250 employees. After the tenants go home, the building's 183 custodians go to work. Every night, they clean and polish 300,000 square feet of marble. Plumbers are on round-the-clock duty. They mine 70 miles of pipes and 1,100 toilets.
There's 3 plumbers in the Empire State Building. We handle all the maintenance, the disasters, and we get help from the other departments when there are disasters. Biggest headache is when we have a major line break and the valves don't hold. When there's a line breaks, you know, we're flying out of here. You know, we're usually the first ones up when it is a line, and, you know, we're shutting down what we can, and then the rest of the people come along and try to minimize the damage, try to keep the tenants from getting affected. You know, they'll put it into the stairwells, and, you know, they don't want to put it in the elevator shafts because it affects, you know, a whole bank of elevators when it does happen. Lately, most of the things have been beepers. A lot of people drop a beeper in a toilet, but nobody's sticking their hands in the toilet, so they flush it, and then it gets stuck. Then we ask who dropped the beeper, and nobody will own up to it.
A building this size generates an enormous amount of waste. More than 100 tons of trash are hauled out of here every month.
Usually it's 10 times more than this. This is nothing. Usually we have garbage stacked up to the ceiling. All this is full most of the time.
We get some good garbage sometimes, you know, but we also get medical rubbish, a lot of kitchen rubbish.
A lot of boxes and newspapers.
Actually, it's a very terrific job, and it's also a wonderful opportunity being that we get to help clean one of the biggest skyscrapers in the world. And it makes us feel very good at hand that we maintain this building very clean, so that way our tourists can come and enjoy it.
Regular maintenance has kept the Empire State Building in pristine condition. Experts say that as long as it is maintained, it could stand for centuries. Other buildings on the Manhattan skyline won't be so lucky. But other buildings can't claim to be enduring symbols of a place and a people. The Empire State Building was one of the last products of the golden age of skyscrapers. After World War II, the elegance of the Art Deco giants gave way to the boxy lines of modern high-rises. Why did this happen? Partly it grew out of an argument amongst architects over the best way to dress the frame of a building. The winners were the modernists, who contended that less is more. Their designs got rid of masonry walls. They exposed the steel, cement, and glass components of tall buildings to the world, creating what was at the time considered a bold new look. These buildings were stark, striking, and most important for clients, they were far cheaper to make than the decorative titans of old. Built in 1958, Manhattan's Seagram Building defined the new style. Its shining glass walls and spacious plaza were unique and much admired. Zoning laws were rewritten to encourage more buildings like it. And that's just what the world got. Thousands of uninspired variations on what was soon called the glass box. For decades, few of these buildings climbed above 30 stories. They simply couldn't. Skyscrapers of the past used heavy steel girders and stiff masonry walls to reach their staggering heights. The masonry dampened the movement of the skyscrapers in the wind. Glass boxes eliminated the masonry shell and used lighter, high-strength steel and concrete. That made them cheaper, but the taller they grew, the more they swayed. It took engineers decades to work out how to build lightweight towers that were both tall and stable. Completed in 1977, Manhattan's 59-story Citicorp Center was among the first glass towers to reach skyscraping heights. But in high winds, the building swayed dramatically. The problem was solved by installing a 400-ton counterweight in the tower's sloping top. Chicago engineers tackled the sway problem by wrapping the John Hancock Tower in a diagonal cross bracing. Tricks like these enable builders to take glass boxes up to record-breaking heights. But the second boom in skyscrapers didn't last long. Despite lighter materials and streamlined construction practices, tall buildings still take plenty of time and money to build. In cities like New York, labor costs, zoning laws, and strict building codes have made new projects scarce. Besides, Manhattan is already crowded with landmark buildings. But there are other cities that still have something to prove. Boom towns that want to make their mark by building big.
Las Vegas stands for big buildings. People come to Las Vegas to see big buildings, to see the buildings. One thing that's happening in Las Vegas is we're sort of creating an architecture of illusion, which is, it's sort of reminiscent of great places of the world. I mean, you look what's getting built on the Strip today, and we're going to save you a lot of airfare. And you can come to Las Vegas and take a trip around the world.
The flamboyant architecture of Las Vegas grew out of intense competition. This city is growing fast. It now attracts over 30 million visitors a year. They spend $25 billion annually at hotels and casinos. All that money has caused local construction to explode. One by one, the casinos of old Las Vegas are being torn down. Rising from the ashes are big, bold, expensive resorts that climb to heights rarely seen west of Chicago. One of the latest is the Circus resort, Mandalay Bay. This $950 million project will include a casino, a conference center, an arena, and an 11-acre aquatic park with its own artificial beach and lagoon. Its centerpiece is a 3,700-room high-rise hotel. At 450 feet, 43 stories high, it's as tall as the city's zoning laws allow. In New York, this would be a high-rise. In low-slung Las Vegas, it's a skyscraper. Although it will be draped in Vegas glitz, the tower is a glass box built on a steel frame, just like an ordinary office building. Lawsuits and economics have done away with most of the perils of construction. Today, buildings in the U.S. are assembled by crews working under strict safety guidelines set by the federal government. This is still a dangerous business, but fatalities are rare. Cranes are the key machines on a modern construction site. They come in all sizes. Some are on the ground, some are in the air. By providing contractors with the ability to lift heavy loads and place them with precision, cranes make it possible to build massive structures in record time. The tower cranes that loom above Mandalay Bay can lift 115 tons of cargo. That's the equivalent to a stack of 57 Ford Tauruses. Sailing those kind of loads over the heads of workers requires a calm, focused operator with the hand-to-eye coordination of a fighter pilot.
Crane operating, you got to be a little bit of a lunatic to ever think about getting into some of these cranes, but it's actually a huge responsibility. The crane operator is the one guy on the project when you've got 100 and some odd guys on the deck and they're rigging, moving things around constantly. The crane operator is the last guy in the link to say, wait a minute, that's not rigged properly, it's too much weight, it's not enough weight, it's too much wind. Wind blows all the time in this city. And that has a tremendous effect, a dynamic load, on not only the crane structure itself, but on anything that you're picking up. So the crane operator is that last guy in the line that has to take care of those problems.
We make around $100,000 a year, but we're working a lot of hours. When they put these cranes up, they want to get their money's worth out of them, so they want to work them a lot of hours. We'll work anywhere from 12 to 15 hours a day, 6 to 7 days a week.
Cranes make it possible to assemble this building several floors at a time, stacked up like a layer cake. While workers below fill in the building's interior, iron workers assemble the steel frame up top. These beams are much lighter than the structural steel that went inside the Empire State Building, but they're just as strong, thanks to improvements in metallurgy. The four-man riveting crews of the past have been replaced by welders who can work alone or in pairs. Welding is the process of melting two pieces of steel together, or melting a third piece of steel that binds like glue. Bolts and rivets may look more substantial, but there's no difference in strength. In fact, the weld these men are making could actually be stronger than the beam itself. If the crane operators and iron workers are the frontline troops of construction, the hundreds of electricians, plumbers, carpenters, and technicians who follow make up the bulk of the Army. Leo Estrada is their general. As project manager for Mandalay Bay, Estrada is an engineer who oversees all construction. He has a $950 million investment in his hands, a tight schedule, and 100 new problems that need solving each day.
Yep. All right, thanks, Mark. My philosophy when I walk this building, I expect to see something different every day, something moving forward. I've been involved on 3 circus development projects. We've always maintained a floor a week, if not better. I think the whole key to that is the Las Vegas area. We've got highly qualified workers here in Las Vegas. We've got probably some of the best subcontractors in the world here on this site.
The pace is frantic as workers struggle to finish the high-rise. Each day it isn't open is one less day of room rentals, restaurant bills, bar tabs, and a share of the $6 billion gamblers lose every year at Las Vegas casinos. Months later, the building is nearly complete. It still has to pass an obstacle course of inspections, all designed to guarantee its safety and reliability. But the tower cranes have moved on. Soon the slot machines will arrive, 2,400 in all. And for the laborers, the finished complex will be a monument to months of hard work. For the entertainment czars, it's the latest punch thrown in the fight to build the biggest, tallest, and flashiest tourist trap on the Strip.
We know great civilizations by their great buildings. We'll know one thing about America when we're through the Las Vegas Strip. Americans had fun.
Malaysia's Petronas Towers are serious architectural statements. But in their own way, they're just as flashy as the fantasy buildings of Las Vegas. These gleaming towers demand attention for their looks and for their spectacular height. At 1,483 feet, these are the world's tallest office buildings. But how much higher can buildings climb?
In the case of the Petronas Towers, going from 1450 to 1485 is not really, in a sense, that great a leap. We are working on one right now that's 2,000 feet tall. That's a little more of a leap, but we did a design in 1980 of a 2,500-foot tall building. And what happens is each case, the movements, the accelerations, they just become larger, okay? But you're really controlling the same phenomenon. You're really addressing the same issues. It's just a matter of, can you make it work within the budget or an economically reasonable price that somebody would be willing to pay for it.
For a time, Asian clients were lining up to pay. In the works were plans for a new generation of super tall buildings that would have left the skyscrapers of the West far behind. Then the Asian financial markets crashed. Projects were canceled or reduced in size. It's a cycle that is constantly repeated in the world of big engineering. For architects, unrealized projects are a fact of life. So far, the Shanghai Financial Center seems to have escaped this fate. Designed by William Pedersen, the center will be the tallest building in the world if it's built as designed. Construction has begun, but the building could be downsized or canceled, depending on the economy. Money isn't the only thing limiting the height of skyscrapers. Many question whether there is a need for buildings to get any taller.
I don't believe that the scale of buildings is going to dramatically differ from what we presently have encountered. I think we've reached probably the full potential in terms of the development of the size of buildings. The question is then how do we accommodate that great size into a more human contextual response? And that is the issue that has essentially preoccupied us as architects for the last 20 years. How do you deal with a tall building and make it give to the environment something that will make that environment a very human place?
For a time, people worried that the future would be a very inhuman place. The dense urban concentration predicted by the 1927 film Metropolis seemed an inevitable consequence of industrialization and economic growth. But things haven't worked out that way. The city of the future was not New York, where people clustered onto an island and had nowhere to go but up. Instead, more and more cities look like this. The wide, flat sprawl of the western United States was made possible by cheap transportation and an ever-widening infrastructure of plumbing and electricity. Across the world, telephones, fax machines, and computers have made it possible for people to work together without really having to be together. Many corporations have turned their backs on buildings that double as statements of power. The corporate headquarters of Microsoft has more in common with a community college than with the Chrysler Building. Some say that the day of the tall building is over. The money they cost to build, the energy they consume, and their uncertain place in the skylines of the future have been roundly attacked.
Those that say that skyscrapers are unnecessary and irresponsible, they're making an irresponsible statement themselves, in that the tall building is the essential component of the present urban condition. The only way we can solve the problem in the city is to solve the problem in the skyscraper. Building big isn't dead yet.
For some corporations, stunning displays of prestige and power are still considered good for business. And the urge to build higher goes deeper than the pursuit of profit. Inside every client, architect, engineer, and construction worker lies the spark that created the pyramids and the Petronas Towers. So long as humans have the tools and the desire, they will keep trying to test the limits and touch the sky.